units, obviously new units.
And just general overview.
And the new controls that go on engineered air units. So that's going to be very interesting. Yep.
Okay, so yeah, we're gonna go over just a general overview on like retrofitting, replacing HVAC units. At any point during the presentation, please feel free to just ask a question and interrupt. Okay, so just a little bit about the company. So we are a made-to-order HVAC equipment manufacturer, founded in 1966 with about 1,500 employees. We've got we have 4 factories in Calgary, 1 in Edmonton, Ontario, and down in Kansas. On our website, there's some good literature. If you ever want any information about our equipment, we have all our manuals on there. If you're not sure which manual is applicable, please feel free to call us. If you have the serial number that's handy, we can send you the manuals. There's also some live training videos online, so those are some good resources to start with. So you're thinking about making aftermarket changes to equipment. So when equipment's built at our factory, they get certified, labeled with a sticker. As a manufacturer, we can't really get involved with any changes, aftermarket changes to the equipment, if any of the information on that label is going to change. If the sticker cannot be modified or relocated. If you need to do that, you need to have an ETL inspector to come on site and witness the label change or an amendment, and that's a very costly inspection. They're usually flying from another city. They got anything to add?
Sure. There's always certain types of changes that could be done outside of units. Like some people want to say change filtration, stuff like that's pretty easy. Or maybe you want to add a coil, change some ductwork. Things like that outside of the unit are certainly possible to do. But the more things you start altering outside of it, the further you move away from what it was designed to do in terms of, say, fan operating curve, air that's actually being supplied, potentially horsepower of motors involved. So generally, it's try and find the unit that you need for your purpose. If your purpose has changed, then find something that's suitable for that. And hopefully don't try and modify it too much after the fact.
Okay, so our standard warranty is parts only, so engineered air is a supplier only. It's standard warranty is 12 months from initial startup or 18 months from ship date. Check with your installer though. They will cover usually the labor portion of the warranty. We do have extended warranties available for additional costs. Of course, if you have misused the equipment or modified it or altered it in some form, warranties void.
The extended warranty, what's the time period where you can add to it? Is it under 1 year, 6 months? Or?
Before we ship it, you can.
But what if it's already in place, like the buildings around now? Is there any way we can get extended warranty on some of this stuff?
That I'm not sure. Just call and ask, and we'll take a look. I think I would say it's definitely harder to add it on after it's been shipped.
And installed?
Yeah, like we have to investigate how it's been used from the time it was shipped.
Oh, okay.
Yeah.
You're only a couple months out, so
Yeah.
probably a good chance.
Yeah.
You were talking about making changes to the peripheral equipment. So a lot of building operators, what they've been doing is increasing the filter MERV sizes. And that would put maybe some stress on the motors ahead of time. So would that be a good idea to call you? Would that be a avoidable item on your list of what you warranty?
It probably wouldn't be a voidable item so long as they're comparable in nature. Like a lot of the units ship with, say, a MERV 8 filter by default, or that's a pretty standard filter. With COVID, a lot of people have looked at using MERV 13.
Yeah.
It adds a little bit more static, but generally the units are designed with a 10-15% kind of buffer in allowed horsepower, as well as naturally stepping up in size. So say you have a unit that's requires 9 brake horsepower. you end up going, okay, well, we should have at least a little over 10. Well, your next size of motor is 15. Maybe you're already in a safe spot. Would that be something to talk with or ask engineer about? We can find out, look at the unit, see how it was designed, how close it is, and go, is a little bit of change in static actually radically going to affect, you know, your fan performance curve in the first place?
So how does that affect the curve from 8 to 13?
It's not bad. Our loading factor that we look at for a MERV 8 filter, which 50% loaded, is about a ½ inch static, a little bit more. I think MERV 13 steps that to about 0.7.
Yeah, we pretty much consider
Okay,
it
so,
the same.
so a phone call would be in order?
Yeah,
Okay.
give us a call. But of course, if you're gonna jump to a HEPA filter, that's
Yeah,
a whole
that
other
is, yeah.
story, right? So we'll take a look at what filter you wanna upgrade to. We'll
Yeah.
look at the fan curve. If it's adding a lot of static, you're gonna lose airflow, and you need to get it rebalanced.
Okay, good, thank you.
We'll talk about replacements.
Sure. Okay, so we're going to talk generally about replacement. So the first thing to think about for replacement or repair is, what is the lifetime of an air handling unit in the first place? So we can think about what type of unit do you have, because that can be a huge factor in it. So if you take an air handler that just has, say, a couple of hydronic coils in it, heating coils, cooling coils, no gas fired in it, nothing else that's really specific to it, you go, well, that unit could last you decades of time, because the actual components in it, aside from, you know, bearings, that type of thing, don't wear out particularly fast. So we have units like that that are in place from the 70s still. You start looking at something that's gas fired, you go, okay, well, if it's direct fired, you don't have a heat exchanger, again, you can get decades out of it, but you're starting to look at lower lifetimes. You look at things that have condensing coils, evaporator coils, refrigerant expansion in them, or indirect fired heat exchangers. Well, you start having a whole lot more type of heat stress on those units as they operate over time. You might be looking at more like, say, 25 years in a good environment for it. You're not always operating in a good environment. So we can see, if you take a look, there's a picture of the unit at the bottom. I think that one's operating in a potash environment. That unit is only 5 years old, I want to say. So depending on what environment in, it can drastically change what the lifetime of your unit is, or change what your usage scenario is. So if you have a unit that's turned on only during occupied hours, and it's only recirculating air in a space, very little outdoor air, it might not have a huge load on it for its whole life. It may not be running 24 hours a day. Versus you have a makeup air that's running 24 hours a day, every day of the year, your lifetime of those components could change drastically. So the considerations are, again, what type of components you have, what type of service it's actually in, and then looking at, okay, how are things changing? Aside from just general age, we want to change it because we have a change in application. There's new tenants in a building space, the space is being repurposed, the space is being expanded. Do you have a critical application that you need something that just absolutely has to work in this space? Failure is not an option. We might look at, okay, we're approaching what would be an appropriate lifetime for the unit. Maybe it's preventative to replace it even if failure isn't imminent. The other thing that you might look at too is costs of failures of major components. So what's a heat exchanger worth in a unit that's 25 years old or 15 years old? What's right now a big one that we're looking at, or I've seen especially in the mechanical contracting side of things, is refrigerant. Going, okay, anything manufactured before 2010, certainly before 2005, is going to be R22 based in an AC application. If you have leaks, okay, now you got to repair it, which is expensive enough. Now you're putting in refrigerant or even a drop-in replacement like a 407C or an MO99 that are decently expensive by themselves, and you're starting to sink a lot of money into a unit that's already, at least at this point in time, 15, 17 years old. So those are the type of things you're looking to weigh when considering when it's time to actually replace a unit. So there's not a, if it's this age, you should look at replacing it, depends on all those things, but those are the things to keep in mind when looking at when you should replace versus repair a unit.
I'll just add something here on my own card, giving you a plug, okay? It doesn't happen very often. But anyway, over the years, I've probably been operating and working on engineering equipment for at least 40 years. So what I've found is we're lucky here in Calgary because we have, you know, the main factory right here, and you can get parts. And so you can, yes, with due consideration, you can rebuild just about anything. If you've got the unit serial number, you guys can look up all the information on that unit for the build and get you the right stuff. Even if you're just doing the changing bearings and shafts and stuff like that, do it so you don't get stuff that you thought was the right stuff, but it isn't. So I'm just saying, good advice to someone who's been there, done it, get the OEM stuff, you don't have any problems.
And
It's
that's
a
the
beautiful
key.
thing.
Get the serial number. They're on there somewhere. Sometimes it's hard to find. Sometimes you gotta open up some
The blue tag.
cabinets. Yeah, look at the control panel. Find a label, get the serial number, call us, give it to us. We'll search it up. Most likely we'll still have original records of the shop drawings, and we can cross-reference original parts versus new parts that's you know, that are compatible. So.
Sorry,
Yeah.
can I ask a question about the heat load of the building? Because in regards to Les, the question about the filters, there's also in connection with during the pandemic, there's no tenant inside the building, and then some of the buildings actually they change their lights to LEDs, and then those are really important when it comes to heat load in the building. And then I've noticed some of my rooftop units, and then they've been pushing harder than the normal previous years of operation. I'm just wondering what's your comments about it.
What do you mean by pushing harder?
Because there's no tenant in the building, and then typically, they added on the equation that, and then LED lights becoming normal now in the building. And then I have an issue in one of my units, and then they said that these units is almost at max because there's no people inside the building, and then we changed the LEDs. So.
Yeah, the engineers, they design a certain heat load, and those heat loads are quickly going away.
Yeah, no, I know exactly what you're getting at.
Yeah.
As soon as you're changing your lighting, a big one is computers for sure. If you look at server room applications, or if you had just computers in space, old computers, the heat load coming out of them is very, you stand next to them, you can feel it. You walk into a server room these days, there's a lot of virtualization, smaller machines, more efficient usage. Even computers on desks are often laptops or something that's very small and has a less than 100-watt output. So that's something that you can look at in replacement. We'll talk about replacement considerations with, has your application changed? Has the load in the building changed? Another thing for adding heat that is something that could have changed and has come up in light of COVID is people wanting more outdoor air in a space. So as soon as you want to let more outdoor air in, suddenly you're looking at load changes as well. So is your equipment built to actually handle those coldest days of the year now? So it's absolutely something, if you're at the point of replacing and investing in that type of thing, going, okay, do we actually have the same conditions as when this equipment was put in 25 years ago? Things could have changed quite a lot. So,
how do they manage that on the design side of things? Because if there's more and more let's say outliers contributing to that heat load, plus they got to stay competitive at the bid stage, do they add extra heat load? Do buildings accept that just for like a safety factor for these sorts of
That is gonna be something to talk with a consultant about. If you're
Yeah.
getting to the point of heat load analysis in
Yeah.
the building, as a manufacturer, we might look at it and go, we're not sure if this is correct or not, but ultimately, we're not deciding that. We're responding to a change and going,
Yeah.
well, can we take a unit now and put a bigger heat load, or like bigger heat exchanger, bigger coils, whatever it is that's required to fit in the footprint that you might already have, so that we can help you accommodate that load.
Yeah,
That's what we'll be ending up looking at.
yeah.
Some consultants are taking into account the global warming and other things.
Oh, yeah.
And you have to be careful, you gotta size your equipment properly. Oversizing is sometimes bad, it's undersizing.
Yeah.
Absolutely. We were talking about that today. There were some people looking at designing air handlers for substations where they have obviously a huge heat load in an electrical substation. And going, well, this unit's gonna be in there 30, 35 years. What's our hottest day in 2050? And then trying to design for that, which is a very challenging thing to do.
So, like you said, sometimes oversizing is not a good thing. We recommend all new equipment gets air balanced. I would say the most common issues we find with new equipment is improper air balancing or lack of air balancing. Oftentimes, the external static pressure will be overestimated. What's actually on site, you have much less. Most of the time, our units are over delivering. We also, again, we design for 50% loaded filters. You got brand new clean filters in there. It's just a bit counterintuitive, but the more airflow, less restriction, you're actually drawing more amps. So and also, yeah, like just get it. This is the first thing to look at. If you're having issues with your equipment, check the balancing report. Give us a call. We'll take a look. But yeah, it's a very common thing. Okay, for roof curves. So there's all kinds of roof curves out there. Of course, it's sometimes you can't measure every dimension you'd like to, but you want to get close to, yeah. We'll match it. You can get curb adapters. It's a little bit difficult to measure the inside, the air openings, but for more often than not, we figure it out. We'll make it work. We'll make it fit. I think you have a lot of experience trying to make these things fit.
Sure. One thing that's very helpful is, again, because we have drawings from the units that we built going back to the start of our manufacturing, so long as it's physically possible, we'll build a new unit that will fit in the same footprint, cover the same curb, which is very handy from an installation point of view. One thing that can happen when you're trying to retrofit units, and I've seen it happen a number of times, is you can end up with adapter curbs on them that can be 4 feet tall, awkward in size, which then makes serviceability of units very difficult. I was up on a roof of a apartment complex that was retrofitted about 2 months ago, and now the unit's 6-7 feet in the air that you have to take a ladder to while overlooking about an 8-story drop about 5 feet next to you. And it used to be on the level, but because they needed a curb to make it work, it makes it now very difficult for everybody to service. So that's one thing to look at, is can you actually fit it nicely in the same spot? And if it's a unit that we constructed, likely we can do that for you.
Would it be ideal for you if it was an ICE unit, for instance, that we sent over the shop drawings for the original ICE unit you can build to that footprint without curb adapters, or?
Most of the time, the answer would be yes. So long as the unit that was there in the first place was using decent physics and how it's constructed, things were far enough apart between sections, airflow was proper within the unit, then we're going to be playing by those same type of physics rules to try and make a unit that, yeah, we can absolutely try and make that footprint work.
We often replace other manufacturers, and sometimes we don't need the drawings. We have a good catalog, a list of just models if they're off the shelf. But We just, most of the time I just go on site with the contractor, we figure it out and it works.
So I'll just interject here, some of the most common challenges, is there enough gas? That has to be dealt with. Is there enough power?
We've got slides on both of those.
And weight. Weight is a big thing. Your roof loading could be completely different. So sometimes when you're doing a retrofit, you have to get a structural engineering assessment, and you might have to beef things up. All of those things are common things to do. Not a big deal if it's done right, but it's not good if it isn't done at the time of replacement. Because then it becomes a shit show, and nobody likes shit shows, because nobody makes money on shit shows, including the manufacturers. So, anyway, just my advice to you.
Yeah, you know, your snow loading calcs today might be different from 20 years ago, so don't expect just because it was done 20 years ago, you can get away with it today.
Yeah.
So, yeah, it's same, you know, same but different. So like, products get obsolete over time. New tech, higher performance. Usually, these days, people are requiring higher efficiencies. Higher efficiencies need more metal most of the time, bigger units. For example, higher EER ratings on your coils. You know, that's just, you need to achieve those numbers. You need more copper. So, and you know, like when replacing, it doesn't necessarily have to be like for like, but yeah, take a look. Has anything changed with the building? You know, like is the heat load different, or can you improve it in some way? And that's a good opportunity to do it when you're doing a replacement. And again, consider clearances. You know, you need proper clearances for airflow to meet your performances. You know, the big one is your jump back clearance for electrical. You need at least 1 meter. It's all on our manuals, what we recommend. Kurt?
Sure. One of the challenges that is super common is mechanical equipment, especially of a certain size, is put into buildings often before construction is complete. So that can be before all the walls are up, before the roof is up in some cases. And you end up with units in spaces that are going to come out using saws and torches, and replacing them, then you go, okay, well, what can you do to easily get new units into this space? One of the solutions to that is splitting units. So you can see the lines on the unit schematic here that show the number of pieces that it could be broken up to, and then wheeled through a 34-inch door. So if that's the type of access you have, it's possible to build units that can actually be put in that way. So you're looking at considerations of your space. Do you have a door that you can use? Hopefully a double door. That'd be really nice. Do you have to get something up and around stairs? Or do you have maybe an alternate form of access that wouldn't be that difficult to do? I've seen situations where taking off a louver and some ductwork to the outside of the building might enable you to get pieces that are 4x4 through a wall, where getting through a stairwell around a corner or getting through a door just wouldn't be possible. So if you have a unit that you think is old, it's problematic, but God, how are we going to get this in or out of here? The out part is, like I said, torches, but the in part is actually not that crazy as well. It can be broken down into very small segments if required.
Yeah, so the other thing to consider is serviceability. You know, this unit was broken down in 11 pieces put together. The middle, this triple blower, of course, the middle blower was very difficult to access and service. So there's some considerations. It's nice and all, you can get it in the space, you feel good, but when it's time to service it, how easy is it to access all the components? Yeah, every inch counts. We'll make it fit, like, but try to share responsibilities. You know, contractors, suppliers, everyone take measurements, do your due diligence, and make sure that we're all working together to make it happen. Let's not, sometimes it doesn't go smoothly, right? But we try.
Okay, so briefly we started talking about gas considerations. So there's a few things for gas considerations. One is what you have existing appropriate? So let's not assume any changes are being made. There are scenarios where line sizing requirements or venting requirements, if it's an indoor unit, may no longer be sufficient to gas code. So there might be chimneys that were allowed to operate that now you cannot vent an appliance in that way. And even if you put a new one exactly in that same spot, it wouldn't be permitted. Or you'd have to talk with the authority having jurisdiction to negotiate that. So making sure that then you, again, had the line size properly in the first place. Now if we're talking about changes, there could be other things to go along with it. So you could have, again, if we're talking about adding heat load to a building, well now we're talking adding gas load to a building. Do you have the base pressure that you need in that space for those gas lines? Do you actually have the gas at the meter in the first place? Lots of buildings are tapped out in terms of gas capacity. Adding 1 million BTU could be a giant thing that actually might not be feasible with your meter set up, and you have to talk to the gas provider to actually work through that before dealing with the piping in the rest of the building. And location is a big part of that too, because location of appliances can often move in retrofits, especially if they're smaller. Indoor mechanical rooms can get sort of rearranged. Well, that can change your line sizing now if you're suddenly 40 or 50 feet further from where the gas connection originally started at your one unit, and the heat exchangers are now in a different part of the building. And the other thing with venting, at least for appliances that are indoor, the material might have changed as well. So you may have had something that was vented with a traditional A vent or B vent style prior, where now you have an appliance that has positive pressure and you need a stainless steel connection, stainless steel venting. So there's a whole bunch of considerations for what your gas and venting will actually look like that you have to look at ahead of time with your mechanical contractor. And the other one was electrical considerations. So probably the biggest one is amperage. Is the amperage of your appliance going to change? So this could happen for a couple of reasons. One, with efficiencies in air conditioning that are now required, and compressors that weren't nearly as good. So reciprocating compressors that were from the 80s or 90s, replacing them now with a scroll compressor on a unit that has condenser fans that have lower horsepower, bigger coils. I've seen it where suddenly your breaker size drop with a BTU for BTU replacement. That can be a really big deal if you haven't looked at it, your contractor hasn't looked at it going, we have a panel that's from 1950 that has a breaker in it that we can't just replace off the shelf anymore. So looking at, is your electrical load changing for being smaller, can actually happen for that reason. Larger can also happen for the same thing, adding capacity. It's hotter out. You may have more of a heating load in the building that you need to cool in the summer. You may have more outdoor air that you need to cool and deal with. So now do you have the proper wiring there in the first place? Do you again have the proper size disconnects, proper service? Can your sub panels support what's actually providing to the unit in the first place? So those can be really big things to look at, but they're also very straightforward. If you know you're changing the application or you know you're changing the appliance, just be aware that you're going to have to look at it, and there could be substantial electrical changes in the first place. Also, it's possible that wire that was pulled and acceptable is no longer acceptable. Maybe you have aluminum conductors if it's an old enough building. Maybe you just have conductors that aren't sized adequately anymore for the conduits in which they're run. Also possibilities. So
Yeah, so we provide on-site startup assistance, highly recommended, especially for gas-fired equipment. So our service tech will go out there, adjust the firing rates, you know.
Is that part of
combustion
commissioning?
levels.
Would that be part of the commissioning?
Yeah, like,
Could that be considered, when you start it up, that'd be the commissioning of it?
yeah, exactly,
Okay.
yeah. So we go out there and assist the installing contractor. We're not allowed to touch anything outside the equipment, just what's inside ours. You know, of course, we tested our factories here in Calgary. It's high altitude. We ship it all over the place. Sometimes at sea level, and your air density and your gas mixture is off. So that's an important thing.
So we'd get a report on that once it's done, commissioning report?
Yeah,
Okay.
yeah. It's.
So when I send the serial number in, I should get that commissioning report?
Like from us.
Yeah, no?
Just call us and ask us, we'll look into it,
Okay.
what's been done. But, like, if you purchased it directly, but typically you'd go through the contractor that it was sold to.
Yeah,
Yeah.
okay.
The heat exchangers, of course, there's a lot of labor involved to change them out. The easiest way usually is to pull them out of the roof. There's quite a bit of panels to pull out, but they get changed out all the time. It's not an impossible task, but of course it's a lot of labor involved. And same for energy wheels. You know, on our manual it tells you the lubrication intervals, like set screw torques and all that stuff. Again, it's not too bad, but they're heavy. They can pull out from the side. You can remove the panels off the casing. I believe the way we drop them in is from lifting lugs above the heat wheel itself. So if you have to crane it, there are lifting lugs connected to the heat wheel already. Okay, this is a common question we get asked a lot. Can we add cooling to your existing unit? So it's not as straightforward as, usually you can't just add a coil in the duct and say you're good. You gotta look at your application, how much static would that add to the system. You know, you gotta look at your velocity. So for example, a direct fired makeup air unit, you have high velocity airflow through there. Likely your coil is gonna require a larger cross-section area. You gotta look at, can your existing motor handle the additional static? If it's makeup air, what happens in the heating season when you're not using cooling? You gotta consider frost protection. You don't wanna freeze up that coil and clog up your airflow. Look at the existing controls and the new controls you're gonna put in. How can you tie into the existing controls and make it work? And again, you add filtration, and of course the weight. Can the roof or wherever you're mounting it can handle the additional weight. For coils, we have all kinds of forms. We can replace and build most of the types of coils out there. Of course, you know, we come to site and measure it, and again we want to share the responsibilities with the contractors, operators, make sure everyone's in agreement with the measurements, make sure it's going to fit, we can get it in place. You know, you got to think about your access. When you pull your coil, like Kurt said, it's easy to pull out. You're usually cutting these things up, but can you get it back in? So sometimes it's not like for like, but we can get close to the performance that you need. You know, we have to do multiple coils to get it in place. That's common. Okay, so our track family controllers have been out, I think, since the early 90s. They have been phased out recently. You know, it's time, but also mostly you can't get a lot of the microchips anymore. They'll stop making them, so we have to start building our new generation of controllers, and we call them, yeah.
So, you were mentioning earlier about matching up the additional equipment for cooling with the control systems. So in cases where there's older controllers, for example, some of the software program that's in those controllers are actually proprietary type software programs, right? So I'm wondering, are you able to update that software and put it in, because each unit is specially designed for its purpose, right? And then we're adding on cooling, so you're adding, and you talked about adding existing controllers so they control the additional cooling, right? So I'm asking, my question is the proprietary software, is it available? Or do we have to rebuild a controller to match the addition of cooling? Because in my experience, I found that these proprietary programming in the engineered air controllers has posed a bit of a problem with regards to adding more. And I'm wondering, does engineered air allow us, or able to sell us the upgraded software or program for the controllers?
Yeah, I think the easier solution for that is, yes, replace a full controller that's programmed for the new application. We'd also build new revised wiring diagrams for the unit. But you have to look at it on a job-for-job basis. There's not really, depending on what controller we're talking about and how old the unit is, it's not really a straightforward answer. But I know what you mean. If it's an old unit, most of the time, say like it doesn't have cooling, it's heating only, you end up with just having two thermostats. Maybe one does heating, one does cooling, and you end up just locking it out, make sure you don't do both at the same time. You don't necessarily, most of the ones I've done anyway, you don't necessarily need to make any modifications to the existing controller. You just figure out a way to rewire it so that it can function the way you want it to function. Yeah.
Thanks.
Yeah, so our new family of controllers we call Cencon. We have a base controller that's supposed to be more economical. It doesn't have a screen. And then the Cencon controller's got a display screen that's also got backnet capabilities built in. And it comes with a variety of expansion modules. So this is just our base controller, which can do most of the function. They actually function very, very close. You know, it can do all your direct fired, cooling, indirect fired, all that stuff. For more complicated units, we would use a Cencon controller, or if you wanted backnet and just some more capabilities, this thing can just do more. I've been told that we do have about 10 years of supply for replacements of our old track controllers. There's no current plans on any kits, retrofit kits of new controllers to old units with old controllers. However, that will come up at some point. A lot of the logic built into the controller is very similar, and we're still using the same parts. So as far as we can see, there shouldn't be any problem retrofitting the new controllers from the old controllers and the old units.
One of the things that we have now that Arvin was talking about was this Cencon controller. Aside from having a nice touch screen and user interface on it, it does have the ability to do backnet control or Modbus. So when we're talking about replacement options, one of the things you can look at is, instead of just being a direct replacement, if the application's changed, or has the building management system changed drastically. When the unit went in, you could have been on a pneumatic system that had very simple, pneumatic electric relay type of control to stage cooling, or simple on-off control. Now you can go, okay, well, what do we want to integrate with? We could have 0 to 10 volt control of discharge temperatures. We could have that for, if we're putting VFDs in, control of fan speed. Could also have benefit of having something like BACnet is communication with the unit as well, actually getting set point readbacks and feedback from the unit directly. So that's something that's now very directly possible with the new line of controls, even though they're set up in a way that's designed to work very similarly to what the old set of controls were.
And if you have, if you have our track controllers, they are in limited supply, so please don't throw them away. We'll take them. We will see if we can refurbish them.
Tim Horton cards?
Sure. Connection. So these controllers, you can connect to them with a Cat5 cable straight to your laptop. It's as simple as plugging in the IP address on the computer, and you'll have access to set points, all kinds of information, what it's doing, alarms, all that. You can also plug it into your phone, but you need one of these adapters, whether if you have an Apple or Android. So this is the interface you'll see. You just go on your web browser, whether on your phone or your laptop, and you can access all kinds of information about the unit. If you wanted to change your set points or any parameters, you can do that there. So, yeah, just a series of alarms. Yeah, I wasn't going to go in too much details into that. But that.
Sorry.
Yep.
One question on the, if the customer had purchased the unit with the base Cencon controller, and a couple years later decided you wanted to integrate to a BACnet system, can they get a BACnet card for that Cencon controller, or do they have to replace that controller with the one with the LCD display on it?
Yeah, it'd have to be replaced with the Cencon with the LCD display. And even if it's not ordered without that, it has to be ordered with BACnet because it's a different program altogether. It doesn't need like an additional card, but we do have to program the functionality into it right from the get-go.
What about plugging in, say, a Desigo BMS system or something, instead of having to go up on the roof and look at that little screen, having it plugged into the BMS system? Is there a capability for that, or is that limited to certain controllers?
It's not particularly limited in that with either, say, Modbus or BACnet connectivity, whatever you're using as your BMS system, that can be graphically designed and integrated to show up as a unit with direct feedback, the way you would any other BMS-capable communicating device.
So control as well as monitoring, or
yes,
only
both,
monitoring?
both control and monitoring.
And monitoring.
Yeah,
Okay.
so you can have that function built directly in.
Okay.
So yeah, the screen is great for servicing and being up there, but yes, if you don't have to go up however far it is to your unit and go out in the middle of a cold or blistering hot day.
I have a question, which brings up a good point. So what's the temperature reading on those controllers?
Those type of controllers, they're good to -40.
Yeah.
So they only get to -40.
Well, and then you need an insulated cabinet that has a heater in it. That,
So-
the units can be built
So it's
higher.
very important that you know that you need to order them correctly, so that you have a NEMA 4 heated enclosure, otherwise you're gonna have problems. And anything north Edmonton, you're automatically gonna have problems, but even around here, we can have problems, so.
Yes, depending
that's-
on where a unit's ordered for, there's lots of considerations for, yeah, do you need a different type of enclosure for your VFD? Do you need a different type of enclosure for your
Yeah.
controls? How are you gonna, yeah, are you near somewhere that's an open field that's going to be drafty and have, there's so many different things that are location specific, but yes, absolutely, that's required in a number of scenarios.
So then, my next question would be, are you still using ball-door motors? You're still using, what VFDs are you using these days?
VFD, if we can get it, ABB.
ABVs
Okay.
are standard,
Okay.
but right now it's just
Tough.
you look at what's available.
Fair enough.
But
Fair
all
enough.
door for the most part, yeah. Yeah, and that's pretty much our presentation. Anyone else got any questions?
Take a shot.
This is a question about the refrigerants of what we talked about. Like, every couple years, 5 years, they change the rule, like the environment and changing that kind of refrigerant. So these compressors, like when you go there, sometimes some tenants, they ask for to get that use or something, to get special refrigerant or something on that, so we have to take out the old refrigerant and get a new refrigerant for that particular system. So my question is that possible to replace the refrigerant like after, like that gonna be adaptable for the new systems?
For the new
Or-
systems?
Sorry, for the old systems, but for like.
Yeah, for the old systems, you're looking at something that's compatible with either the pressure range, so an R22 replacement, you're looking at an R422D, R407C, MO99. Some of those you can use with either type of oil, either a synthetic or poly, or either type of oil. And whereas like 407C, you actually have to change the oil when you do a retrofit. 410A, because it's still in production right now, and will remain so for, there is no moratorium on date for production of 410A. There aren't drop-in replacements for it really right now. There's been talk of 2025 and then 2030. There's a lot of companies are doing research into what they are looking at for a lower ozone depleting, or not, sorry, global warming potential refrigerants, but nobody has stepped in fully. And until a large manufacturer who's doing bulk items really takes the plunge on it, that the rest of industry is not going to follow along. It's just, you have to have the compressor manufacturers and all of those components, as well as the then unit manufacturers, all agreed about what they're going to use, and that consensus is still up in the air. So I don't have a better answer than what's the future
Because
exactly.
we had that issue before, and like sometimes they ask for changing that refrigerant for special and code engineering, all this stuff, but like some of them they said change the valve of the compressor. So they give many things like, but at the end we like couldn't give a good answer because that's going to be challenging.
Yeah, and until there is a industry-wide adopted new standard, knowing what change-out options will exist long-term for, say, R410A, like what are you going to do with an R410A change-out in 2035? I do not have an answer for that.
Yep.
You'll have to excuse me, I haven't been in the industry like hands-on in about 7 or 8 years, but my question is going to be on filtration because that's my background. And the pandemic obviously has raised the spotlight on filtration, outside air. And you talked briefly about going from MERV 8 to MERV 13. So my question is on the hardware. Like when you go from MERV 8 in the U channels, and the one picture you had on the filter, to me it's a very porous and not very effective filter hardware. And you go to MERV 13, as you go up in efficiency, the hardware has to keep pace with the filter. Have you changed the filter hardware? Like especially the customers now are asking MERV 14, 15, and 16. You can't, or you shouldn't be using the same filter hardware.
Oh yeah, and it's got to be face loaded with seals around it. Yeah,
For side access, or how do you?
Yeah, so that's what you got to look at. Is it even possible? So to get that level of efficiency on your filtration, you can't use the side filter racks. Now you got to look at.
Yeah, but you already have some that you're retrofitting, probably with the same channel right now, and you went from MERV 8 to MERV 13. Are you doing anything with the U channel tracking?
Nope, that one
you
usually
change the
just
tracking at all, or?
Nope, that one just stays. But it's up to the end user if they want to change that.
What options do you have for somebody that wants to change it?
Well, whatever you want to do inside your unit for for changing a track, I mean, that's not a big difficult thing, that's especially on an older unit if you want to go down that road. What I've seen people do, the biggest issue with, say, 2-inch pleated filters is usually the gapping in between them is one of the biggest issues, which is why face loading is important in actually sealing them and keeping them in place. In retrofits where people weren't worried about 100% filtration of the air, the filters were in there for dust, right? They're for almost nuisance was the original purpose. I've seen taping of the filters as they get side loaded, so there's no gapping between them, and then the filters are pushed against the top of the channel when they get sucked in, but they actually seal decently all around it. But you then have to make sure you don't have gapping at the side of the unit either, which if you have insulation that's drooped over time, if you have blank plates that have been thrown away over time, which I'm sure would never happen. Yeah, you may have to get creative if you're side loaded with an existing unit and you're trying to get a little better way of sealing those filters in.
I think my point is there's better tracking out there, and I just don't see it. I haven't seen it in the industry, and correct me if I'm wrong, if it's happened in the last 7 or 8 years, but there's all kinds of pressure and sealing mechanisms that can be used, especially as you start increasing in MERV.
Yeah, I think that starts
Is that
in
an option at engineered air, I guess is my point on that.
Yeah, I think it has to start though with the consultant and to specify that, because if you're doing competitive bidding, suppliers aren't just gonna throw that in because it's the right thing to do. So they gotta, it's gonna get specified, and we'll find it and we'll use it.
So it's not something you use right now?
It's pretty rare. I haven't come across it.
Okay, no, fair enough. It's just my.
Yeah, I've seen stuff like, of course, UV filtration got popular. There's retrofit kits for that. You can throw them in units. I've seen those electrostatic filtration, all kinds of new stuff.
Bipolar ionization.
Yeah.
Yeah, it might be a good idea if, because it is engineered air, that if they are going to use that kind of filtration system, it might be one of those things that you'd put on your little checkbox to say, do you want to increase the stock filtration steel just to hold it in place?
Yeah.
Yeah.
Absolutely.
It's like an
It's
extra
option.
bonus.
It's an option.
An option, yeah, an option.
And some of them are, the newer filters these days have less resistance as well. That's what I understand, is some of them are actually trying to say that, yeah, I know, that's exactly, I know, I understand the smile and the chuckle over there, because it's on paper, but I've never actually seen it in works, and it sounds like a great way to sell filters. But
I would use
that is what I'm hearing, is that they have, some of the newer ones are now with less resistance in the way they built the old ones too, so that might be part of that.
I'll bring up something that's sort of with the filtration. You just sort of glanced over the heat wheel thing. The engineer was making their own heat wheels, still does, I'm assuming?
Yeah, absolutely, right here in town.
Yes, and you know, I've been around these units for a number of years. When it first came out, we had some balance problems. And, you know, worked through that. You know, filtration is a big deal when you have a heat wheel. And you can destroy the heat wheel very quickly with poor filtration. So if you're going to be putting a heat wheel on a unit, better explore some alternate options for filtration. Because the way they come out of the factory
Doesn't cut it.
I didn't say that.
I did. I have to say, yeah. No, it doesn't. I mean, I've seen an awful lot of them.
So if that's a feedback from the
fair
field,
enough.
you know, like, take that back, sell it.
Sure.
They'll pay.
That's good.
So I think we're just about wrapped up here. One more question?
One more question, yeah. It's going back to when you started talking about the ETL label and the modifications of retrofitting an air handling unit. It's fashionable nowadays to be installing VFDs everywhere we can, and there's an attraction to some engineered air units, for instance, to get rid of the across-the-line starters for no other reason then to reduce belt maintenance and improve the power factor of the system, reduce energy costs. And I don't know if you can answer this question because you're the manufacturer, you don't want to put your foot out there, but do you think that goes against the ETL listing? It doesn't really change the sequence of operation, it's just being used as a soft start, so to speak? Or?
So the amp draw, if you do the calculation, sometimes the motor, like for the same horsepower VFD and motor, they have different FLA ratings, so that will affect the label. So for example, how we do it, our electrical calculations for a new unit, if it has a VFD, we use the VFD ratings, not the motor. So again, yeah, that would, it may not make a big difference, but yeah, sometimes it would change just a slight number on that label.
Okay.
Excellent. Well, thanks a lot for giving that comment.